Hey everyone, so today we are going to start with event loop. We are going to actually end the series. I'm quite happy completing the series and um, we'll start with event loop and uh, with event loop, the best thing that I remember is that no one can explain event loop better than this video that I saw once. Some Archibald guy. Uh, what I remember, event loop Jake Jake Archibald. Yep. Yep. So I guess this is the best explanation for event loop I can find, and um, I saw it like a year or two ago, but yeah. Um, and I was a fan. When I saw this video, so event loop JavaScript has a runtime model based on event loop, and uh, today we are going to do concurrency model and event loop. Like I'm recently learning Go, and I'm a good like I am a fan of Golang right now, and like Go is totally based on concurrency models. I think understanding JavaScript concurrency model and then comparing it with Go will help me out a lot, help you guys understand. So I guess that would be the philosophy that I'll take with this video. JavaScript has a runtime model based on event loop, when which is responsible for execution of code. Collecting and processing events and executing queued subtasks. This model is quite different model from other languages like C and Java. Yep. Runtime concepts. The following section explains theoretical model, modern JavaScript engine. So basically, we have a stack, we have heap, and we have a queue. Stack function calls from the stack frame. So um, basically, like const bars is equals to bar 7. So this will call this, and this will basically go on the stack. And let's see the order of it. When calling bar, the first frame is created containing references to bar arguments and local variable. Okay, okay. When bar calls foo, okay, bar also calls foo. I didn't see that. Um, A second frame is created and pushed on top of the first one, containing reference to foo arguments and local variables. When foo returns, the top frame element is popped out of the stack and leaving the bar call frame. When bar returns, the stack is empty. So basically, when bars is calling bar, then let's say this is a stack, then we add on bars is equals to bar on the stack. Then basically this calls foo, bar calls foo, so foo is added on to the stack. When foo executes, foo is popped out. Now we have a bar on the stack. Now bar ends and bar is popped out. Heap. Objects are allocated in heap which is just a name to denote a large, mostly unstructured region of memory. So, like if you remember C++ language, or if you have some or Java, then all the pointers are stored in then heap memory, and the data that is associated with pointers. And like if you when you no, like in C++, those delete operations, free and like malloc functions. A function is basically whatever is stored in. Basically, those objects, those structures are stored in heap. In JavaScript, runtime uses a message queue, which is a list of messages to be processed. Each message has an associated function that gets called to handle the message. At some point during the event loop, the runtime starts handling the message of on the queue, starting with the oldest one. To do so, the message is removed from the queue and corresponding function is called with the message and the input parameter. As always, calling a function creates a new stack frame for the function's use. The processing of functions continue until the stack is once again empty. Then the event loop will process the next message in the queue if there is one. The event loop got its name because it's how it's usually implemented, which usually resembles queue wait for message, queue process next message. Yeah, a while loop basically. And uh, as a message enters, the it creates its own stack frame where like the stack and as it goes out, that stack frame ends. When the stack frame ends, basically it goes out. So this is a synchronous operation, and that's why like JavaScript is a single-threaded synchronous language. Run to completion. Each message is processed completely before any other message. This is a better place, yeah. Process. Uh, this offers some nice properties when reasoning about your program, including the fact that whenever a function runs, it cannot be preempted and will run entirely before any other code runs and can modify data and the function manipulates. This differs from C, for instance, where if a function runs in a thread, it may be stopped at a point by the runtime system and to run some other code in another thread. Yep. The downside of this model is that if a message takes too long to complete, the web application is unable to process user interactions like scroll and browser mitigations with a script for taking too long. Dialogue. A good practice for below is to make message processing short and, if possible, cut down one message into several messages. So, uh, a good example to show this will be like add a script file to your or HTML code and run a while loop, like infinite while loop, while one, let's say while true, and now add a button in your HTML file and add an event listener on the button and try to console log on click, uh, like something like hello, I clicked this button. Now that wouldn't work because the event loop is busy in uh, completing the while loop, and basically, like if you can think in a more creative way, you will think like event loop is just working, running fast. He's like, I'm here, and basically the on click operation tells him that, "Oh, I want to console log this," but then the event log is saying that, can't you see I'm doing this operation, uh, and the on click operation like um, on click message like in their regard message would say that I want this to be done, and he'll say, don't you see that a infinite loop will take infinite time, come after infinite time, and that would never come. So like uh, so yeah, basically, like to test it out, you can basically make an infinite loop and try to run a on-click function on a button, and it wouldn't run. Adding messages. The web browser messages are added anytime an event occurs and there is an event listener attached to it. If there is no listener, the event is lost. So a click on an element with a click event handler will add a message. Likewise with any other event. The function set timeout is called with two arguments: a message to add to the queue and time value optional. Time value represents the minimum delay after the message will be pushed into the queue. If there is no message in the queue, the stack is empty. The message is processed right after the delay. However, if there are messages, the set timeout message will have to wait for other messages to be processed. For this reason, the second argument indices a minimum time, not a guaranteed time. Yeah. So let's say you have a set timeout of 2 seconds. but there's an operation in the queue that takes, let's say, 5 seconds or 10 seconds. So then your 2 seconds, the operation that you believe that it would take 2 seconds will now take actually 5 or 10 seconds. So that's the problem, and but it is what it is. So um, here's an example: set timeout in 500 milliseconds. They are consoling log uh, new return while true. It's when greater than is equals to 2. That's a log good loop. Yep. So what are they doing? When saw 2 meaning the callback is not called immediately after. Yeah, so first time it will be 2. Uh, uh, so this will loop for the next 2 seconds, but the set timeout uh, already pushes on to the queue in 500 milliseconds. So this is what basically happening. I, this is what basically happening. First, uh, like we initialize second, and then after then set timeout is called, but set timeout says that I want this to enter the queue after 500 milliseconds. So now this is the queue, and set timeout is like in the browser. Let's say the browser threads are handling set timeout. Basically, generally they do. Now the while loop is entered into the queue, so it enters the queue. While loop enters the queue, and it is here for 2 seconds. So for 2 seconds, the while loop is here. In the 500 millisecond mark, uh, this set timeout will also enter the queue, but as the while loop isn't finished, it wouldn't be executed. So it would actually get executed after 2 seconds. So that's a problem. The zero basically now let's talk about the zero delay. The zero delays doesn't mean the callback will fire off after 0 milliseconds. Calling set timer zero will delay of 0 milliseconds doesn't execute the callback function after the given interval. Okay. The execution depends on number of rating tasks in the queue and the example below the message. This is just a message will be written in the console before the message in the callback gets processed because the delay in the minimum time required for the runtime to process the request, not the guaranteed time. The set timeout needs to wait for all the code for queued message to complete even though you specified a particular time limit for your set timer. Plus, one thing you also should know that zero doesn't mean zero, so it's actually like 0.01 something. So like uh, set time out 0 actu. Uh, let's just check. I don't know if I can find it. Uh, yeah, it's basically a shortest possible delay, and which is around 10 milliseconds. So basically, it will send it to the browser thread, and then the browser thread will like act basically immediately send it to the queue, but then still like the time taken is like 10 milliseconds, which makes possible to us to do a lot of work. So basically console log, this is start will be console log. This is just the message will be console log, I guess. This is the end will be console log. Then set timeout. This will get onto that and call back from message. Yep. Several runtimes commuting together. A web worker is for a cross-origin iframe has its own stack heap and message queue. Two distinct runtimes can only communicate through sending message via post message method. This method adds a message to the other runtime if latter listens to message events. Okay. Hmm. This is something new. So we can also add post message crossover window objects. I guess those Google and login with Google and all that might be implemented through this because they have pop-ups and like different tabs and then they work. So that's my best guess. This method adds a message to the other runtime if the latter listens to the message event. Never blocking. A very interesting property of the event loop model is the JavaScript. Unlike a lot of language, never blocks, blocks handling I/O or typical never blocking. A very interesting property of event loop model is that JavaScript, unlike a lot of other languages, never blocks. Yeah. Um, Handling I/O is typically performed via events and callbacks. So when the application is waiting for an index-db query to return or an XHR request to run, it can still process other things like user input. Legacy exceptions like alert or synchronous except are, but it is considered a good practice to avoid them. Beware, exceptions to the exceptions do exist. Okay. But are usually implementation work rather than anything else. Okay. Mhm. I guess that ends a JavaScript series. Oh my God. This has been a long time. Almost a month of like actually like 31 videos. So almost a month of doing streams and almost on an average, I guess it would be around 1:45 minutes to 1 hour. So next, I wanted to do Node and React, but I saw the Node documents and it's huge. It's humongous. So, and I don't have that capacity right now to speak for that long. Document reading is like I have read the whole React document and I can do it very quickly, but reading it on stream is a task on itself. And so, and for React, I was waiting upon the new React talks to be complete. So next, I had two requests for TypeScript, and I had one request for React. So I guess I'll do TypeScript. I don't think it will take much time. I'll do JS specific TypeScript. Not I saw. Okay, so I'll do TypeScript uh, for new programmer, JS programmer, and handle book, I guess. So I guess, and I'll change the naming convention a bit. So I'll take topic by topic. So I'll take one topic each. So like, uh, earlier I was thinking that okay, so some days I might take one and a half topic. Some days I might not feel like taking uh like a whole topic, so I would take a half topic. So that was my plan. That's why I used a naming convention where I was using like till this topic, but that doesn't make a lot of sense right now, and I didn't actually do that. I actually finished all the topics that I mostly all the topics that I started that day. So I guess I'll do it topic by topic. Um, that's it, guys. People that did learn, please like share this, like this, show it in the comments, and I'm happy. Bye bye.